Today we will talk about lesson 8.2, the nature of covalent bond. We already mentioned that most of the elements, they try to be stable by following a certain configuration of the nearest noble gas. How we can translate this? We can translate this by mentioning the octet rule. Octet means 8. That means that most of the elements, they try to fill the last shell by 8 electrons to make them within the same configuration as the nearest noble gas, except for hydrogen, because hydrogen, it has only one valence electron, so the hydrogen tries to be like helium that has 2 valence electrons. So hydrogen tries to be stable by having 2 valence electrons. Now, the maximum amount of bonds a certain element can form is the amount of bonds that can make it have 8 electrons only. More than 8 electrons is not acceptable, and for hydrogen the maximum number is 2 electrons. Now, the elements in group 4A, 5A, 6A, and 7A, the ones that there are non-metals, they are the ones who share their electrons together in order to have 8 valence electrons in the outer shell. Sharing means covalent bond. For the covalent bonds, we have 3 types: single, double, and triple. Now I will discuss the single covalent bond. Single covalent bond, how do I determine that I have a single covalent bond? When I have a shared paired of electrons, or 2 electrons that they are shared between 2 elements. Each element should share 1 electron. Example on it is the H2. For the H2, you know that the hydrogen, as I mentioned now, it has only 1 electron, and the other hydrogen has also 1 electron, so they will share these 2 electrons together. So the bond between hydrogen and hydrogen, it's only 1 bond, which is a single bond. How do we write the single bond? Each 2 electrons, they form a certain line. This line, when we draw the elements with lines, is called by structural formula. Another example, fluorine 9. Fluorine has 7 valence electrons because it's in group 7. So when we do the dot structure, I will just add 7 electrons here and 7 electrons here. The free electrons are 1 and 1. I can't share the pairs. I should share the free electrons only. So here I have a free electron, and here I have a free electron, unpaired electrons, so they will share together to form this structural formula. We can do it like this, or we can add the extra dots. If we count how many electrons each one has, there will be 1, 2, 3, 4, 5, and these ones that they are in share, we count them for both. So 6, 7, 8. 1, 2, 3, 4, 5, 6, also 7, 8. So this one has 8 electrons and this one has 8 electrons. So it follows the octet rule. Okay? Now, let's do the electron configuration for fluorine. 1s2, 2s2, 2p5. So this is the electron configuration, how we draw the electrons as arrows, and this is the other fluorine. So when they combine, these 2 electrons, they share because they are free. I can't share from the electrons that they are in the filled places. Now, let's take single covalent bond in compounds instead of elements. Example, we have the water. Here I have the water has 2 hydrogens and 1 oxygen. If we do the dot structure, the hydrogen has 1, the other hydrogen has 1, and the oxygen has 6. So the oxygen has 2 free electrons. Each hydrogen will share this free electron to form this dot structure and to form this formula structure. Now, the hydrogen, because of these 2 electrons, they try to push because of the repulsive force, so we will have this bend shape. That's why the water has a bend shape and it doesn't have a linear shape. Another example, we have here the methane, CH4. Carbon is in group 4, so it has 4 valence electrons. Hydrogen is in group 1, so it has 1 valence electron. So I have here 1 carbon with 4 valence electrons and hydrogens, or 4 hydrogens. Each 2 electrons, they will be shared. So each hydrogen will share 2 electrons or 1 electron with the carbon. So each hydrogen now will have 2, so it's stable. And the carbon in total, it has 1, 2, 3, 4, 5, 6, 7, 8, so 8, so it follows the octet rule, so it's stable. And this is the structure formula. Now, here must be aware that in order to say what type of bond I have, you should look at the carbon and hydrogen. The bond between carbon and hydrogen is single. So the carbon makes single bond with hydrogen, but how many singles? 4 single bonds. So be aware of this. So here I have 4 single bonds between hydrogen and carbon. Now, let's take the carbon configuration. The carbon configuration for electron 1s2, 2s2, 2b2, and this is how we draw it, or how we learn to draw it. Now, by this, here I already mentioned that when I have a paired electrons, I cannot share it. So what happened here? Carbon must, when it tries to make a chemical reaction, it takes some energy from the environment in order to transfer, or to let this electron to go to the p shell instead of being in the s shell, and it will have this electron configuration. So all these electrons, they are free, so these are the 4 ones that they share here. Then we have the double bond. For the double bond, let's take some formulas. For example, the oxygen. The oxygen, I already mentioned that it has 6. So I have here a free, and here another free electrons. So these free electrons, they will share together. We put the shared ones in the middle, so they will form this structural formula, like a double bond. You can add the electrons like this, it's correct, but to be more accurate, we will say that these electrons, they make a repulsion force because both of them are negative, so they will try to push each other to be within this shape. Most of the double bonds, they form linear compounds. Most of the double bonds, they form linear compounds, okay? On the other hand, let's take CO2. Here I have carbon and 2 oxygens. The carbon has 4. The oxygen, each oxygen needs 2. So each 2 electrons from the carbon will share with 2 electrons from the oxygen. So I will say that these 2, they will form together a certain double bond, and I have the extra oxygen unpaired electrons, or unshared electrons. So as you see here, also because of the repulsion force, they will be on the corner. Let's take here another example that I have C2H4. Now, when I'm talking about C2H4, I'm talking about here 2 elements, not only one from each like the CO2. So here I have a carbon, and here I have a carbon. So what should I do? I should connect the 2 carbons, and I should connect the carbons with hydrogens. First of all, connect with the extra ones, then the rest connect them between the carbons. I have 4 hydrogens, so draw them first. 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4. Now, I have 2 carbons and 2 hydrogens, so each carbon will take 2. So these ones are connected, and these ones are connected. Then the other carbon will take 2, this one and this one. Now each carbon has extra 2 electrons. So the 2 carbons, they will be connected with each other. So as you see here, the 2 carbons, they are connected by 2 bonds. So carbon with carbon by 2 bonds, and each carbon make a single bond with hydrogen. Hydrogen never ever make a double bond. Hydrogen only single bond, because it can share only 1 electron, and it needs only 1 electron. So this is the shape. So this is the compound. The last thing, it's about the triple bond. Triple bond, let's take a certain element like N2. N2 is a molecule between 2 nitrogens. You know that the nitrogen is in group 5, so it have 5 valence electrons. So here it's the 5 valence electrons, and here I have 5 valence electrons. So I have 3 electrons that they are not like paired, they are free or single. So each one will be connected with the other end, and I will put them in the middle, and they will form a triple bond in the structural formula. Another example is C2H2. As I mentioned now, I have here 2 carbons, 2 hydrogens. Each hydrogen will be connected to a carbon. Then the carbons, they have 3 free electrons. So what will happen to the free electrons that I have them in both carbons? They will be connected as triple bond. The same thing here. We have here C2N2. Here I have 2 carbons and 2 nitrogens. The nitrogens, they have 3 places or 3 free electrons, so each free they will be connected to the 3 carbons. So between the carbon and the nitrogen, I have a triple bond. While I have here extra 1 electron for the carbon, so they will form a single bond between the 2 carbons. So be aware, where do I have the double bond, where do I have the triple bond, and where do I have the single bond. So first of all, just distribute each one for them. Each carbon will take nitrogen, so here I have carbon and nitrogen. The nitrogen has extra 3 and the carbon has 4, so 1, 2 and 3, so I have 3 bonds. So between the nitrogen and the carbon, it's a double bond. Now I have extra carbon here, it will be connected to the other extra carbon that's also connected to 3 nitrogens, so it will be like this. That's it. Thank you.